please reply. Otherwise, I give whether you are connected or not. Yes or no? The menu, not in the. Okay, you can hear me. Great. So, wait for a couple seconds, a couple minutes. So, you know, some of your previous talking about to do the not so far what we learned. We learned chapter one, and in chapter one we learned how to do the arrows. In particular, to assign the weights for mean for a mean value. How to assign the weights. So how could I decide the weights? So the main approach people by using the standard deviation. So standard deviation basically to stand for how wide the data spread. So the wider the worse. So if the data spread too much, then it's not good representation of your uh, estimation or your approximation. You tend to have data that's much more focused. You tend to concentrate it. It's much more better. Okay, that's one. And also in the second part, we started to talk about the chapter two, and what's the difference between chapter one and chapter two? And chapter one basically is more about the theory and design the ways. That's more about chapter one. And last time we also talked about it doesn't mean we already finished chapter one. It just means we have to move on. And in case at some point we still need the background knowledge in chapter, we'll come back. We'll retest the what we walked through in chapter one. But for a moment, we move on because time is quite limited. So we move to chapter two. So what's chapter two about? Chapter two is much more practical because whatever you learn in chapter two, you will be facing the same problem in the real world. And since we only have 32 credits for this lecture, and we are still discussing. I think in a normal in a class lecture we have something called experimental credits. So maybe that will add up to another 16 credits. And that one will can be very operational. Like you can give a hands on many kinds of machine. But since we are still online, so we'll see in the end how it turns out. Maybe we'll still have a chance to go back to a real lecture classroom, and then we can operate the machine, or we can resort to some online video or something and teach you and how to. Of course, we'll find some video that's much more practical. Okay, we'll find out. Okay, so when we come to chapter two, we talk about how to measure the distance, and it seems like it's a 3 years kids stuff, like how to measure this distance. Every kid, if they hold tape, they know how to do the measurement. They can do the measurement. So it's not something. It's not rocket science. It's basic knowledge. So basically, the hire surveyor not to do is not the main purpose is not do the measurement from A to B. The main purpose is to tell you how to accurate based on statistics, based on a lot of information we learn, to estimate the tape use, the reading use, and then get something called true value between some distance, some range. That's the main purpose of your as a surveyor, your main job. Okay, so there are many problems regarding. Of course, there are many ways to do the measurement. No matter which tool you choose, of course, for example, you can choose the manually. You can choose a tape. Tape is quite universal. Everyone, if you are a worker, you can see. Normally they use a tape. Why? It's cheaper and it's easy to carry. If you use a machine, normally you have to carry a lot of heavy machine and very high technique. And another thing another tool you can use is use an electronic device. You can use electronic, including for example, like a light. You can use the property of the light, or you can use the property of the let's say wave. different kind of tools. Different kind of tool. You can use light or different. If you like, you can even use sound. Use a sound. So there are many ways to do this kind of thing. But no matter which tool you choose, tape or electronic device, there is always some error in the either machine. This kind of error, previous in chapter 1 we talk about is called systematic errors, and now in this chapter, we are going to estimate these kind of errors, and for this purpose, we look at the simplest one, is a tape error. So last time we were talking about what kind of error might occur tape. Normally it's influenced by many factors. For example, like the force you put on the string. Now, and the light is one, and second one is the temperature. Is a physical the temperature. The natural one might apply some natural stuff on the tape as well. If, for example, if the temperature is high, then if you are using a steel tape, a little bit is thing for you. Maybe think is an for example, going to cause huge errors, maybe a couple meters errors. A couple meters matters a lot. So that's the reason how you to do some much more accurate. So you have to according to different kind of force, different kind of temperature, and today we're going to talk about something called sag, the degree of sag. Also, last time talk about if you are measure distance between you are measure between A and B, so you can only climb here to here. But the thing is, you are going to measure the horizontal one, but there is a inclined angle over here. You can get A distance from A to B over here, but you're going to convert into horizontal one, and because the value here is theta, and this value is reading from your tape. So from your tape, you can get this value, right? You can just say this. You can get in, but this is the you care about is influenced by this kind of distance. So you distance between A and B plot. This is on the graph, and this also have an angle. Things have it should be longer, right? Use the readings are longer, but indeed to be shorter, so you overestimate. So how are you going to estimate the errors? So we don't care about errors. We care about what's the real distance between A and B prime. So as long as you can get A B primes, you don't care. You can jump. You can jump Q. You don't have to calculate the errors. No one cares about. We only care about the true. We don't call it true. We call it standardized. Standardized value between A B prime. That's the. And then you might wonder who standardized this bit. Depends on different kind of things. Sometimes if that one is quite universal, you're going to measure something that's quite universal. Someone might tend to standardize in order to get a universal language. Otherwise, standardization is sort of like theoretical things. It's more like theoretical things. It's like okay. So in this case, according to trigonometry, the basic trigonometry in high school is easy. So it's x times cosine theta. So x times cosine theta will be your AB prime. Will be AB prime. So this one will be your standardized. Why is not standardized? Because you are measuring something on a slope, and so you have to get rid of the factor, the slope factor. So if you defect the slope factor, you get this one. This is a horizontal. One is the one you are much more interested in. So it will become this value. Okay, that's one of the one we talk about. And the other one is last time we also talked about this one. This one. And C in the last time we talked is the value is based on error, because according to my derivation of C divided by C in the real way in the standardized value. Let me the derivation I sent you guys. I wonder how many guys have you looked into my because I also home expressions or maybe they understand my writing over here. So let me briefly go through this one, the derivation. Need to derive this one. Is want to make sure every number is not a lightning book like arrow equal. I want to see exactly what do you mean a C arrow. So that's the reason I do this derivation. After this derivation, you have a very concrete idea how to get C and how to get some. Okay, so let me briefly introduce the derivation over here. Okay, so you can look. This is a tape. The tape means the tape you are holding these hands in your hands. The tape is, or you get is a reference in the sense like under which degree, which blah blah blah. Then the length will be this one. This one. So whatever on this tape is as a correct sense like it being standardized or refer to tape. What is better? If we refer this okay. Look, because this reading 20, so 20. So that's a reason correct something called otherwise L is also 20. It's a 20 meters. There are 20 meters long tab. This they have for confusion. I use this I call this distance. We use any. I just call this is this long. All this long. I call it V. Units. I just call it V. This whatever you sense. I just give this. So there is long unit. No centimeter, no meter, just this length. Okay, fine. And this is your tape. This is the reading. And U is the one the same. This is just the length without any units. I just call this long. This length U, without any units. Okay, even without units, indeed that one. This one is just longer. You can see. V is longer. You see, V is longer. U is shorter, without units. By units, they are same. These are centimeters. These are 20 meters. This is 20 meters. They are the same. You can't say the physical difference. The physical one is U physically is larger than this one V, right? Physical, you can see from your naked eye, you can see this is longer and this is longer. Okay, so now we are going to construct the relationship between these two. Since this one is shorter and this one is longer, so there is a difference. The difference between this difference, the physical one, physical difference. Calculated like one, and this was C. C is in this C by this L. Is C. So C here is use this tape. Use tape and use this L. This reading to measure this length. The length from the difference between this one and this one. So this is a physical length. Physical length. So how are you going to measure this physical length? I use this tape. Use this tape. This tape is L is 20 meters. Contribute to 20 meters. This is a small one. So this C will contribute to how much? This is then the total is this V is a physical one. This L is 20 meters. 20 meters. And then now is a C meters. So in total is only contribute to C divided by L. C divided by L. C divided by L times V. So this is a physical one. C divided by L times V. This is a physical one. So this physical one means this by C divided by L times V. Think about it. It's an easy idea. Simple one. So again, let me emphasize again. In the book, you can see is a L is a see the step have one job by C means this C is in the tab, the unit of standard tab. So will be this C will be reading from this tab from L this tab. So you'll see your this reading. So for example, if this tab to measure this one might be, for example, like 0.2 0.2 meters, something like this. But 0. Step. Okay. So next one. Now you already construct the relation between the physical one. So the physical one, this is a reading one, nominal one. Nominal one is a C as from your tab. The read from your tab. Okay, and this one is the physical one. There is no units. There is no units. Okay, next one. Okay, and so now from the physical one, the length of this 40 length I already right, and this one is like C of V is a in total is a V. This physical one is a C divided by L times V. So this is also physical one in V. Okay, so next one. Next one, you make a linkage between this one. You'll get what? You'll get U plus C divided by LV. This is a physical length of this one. The physical length of this equals V. The physical length of V. Right? So U plus C divided V. So this you can equal 1 minus C divided. You can shift U over the V over the other side. You get this one. So V is a relation. This is 1 minus C divided by L times V. This is a relation. Okay. To the next bit. But how about my the reference? Okay, it's the same approach. This length, physical length, U. Where you see U is this length. This length. So you can treat this length as a U as a unit. This unit is called U. So this unit itself is called U. Okay, again, this is the standard tab. The unit itself is called V. This you call this unit as a whole. You could call this unit as V. So this is a unit itself by itself. You don't rely on other. You don't refer to other units. U is itself. Treat this one as a unit by itself. This unit is called U. Treat this self as a unit. This self is called V. But the thing is, this means not reading. Not on your tab. L, you can see is for example, L is 20 meters. It's a tab. Again, this is reading your tab is called 20. So all these are the words written on your tab. You can't change it. It's already written on your tab. I can't change it. It's already written. Okay. So now we are going to tackle what's the relation between U and V first. U and V first. So look at this one. Normally they'll tell you U, this one. The U step is longer then standard tap by C units. So by C, this C means that you use the standard tap, this standard to measure the difference, this physical difference. And then the nominal I read on your readings is a C. Okay. So units, standard units, or you create them for illustration. I don't. This units, this U and this V is just there are two issues to be clarified. The first thing, standard tap. Standard tap, indeed, there is nothing called standard tap. And this, you really standardize something. Otherwise, standard tap is a concept like you fix one temperature, you fix the force, fix something, and you see what's the distance, what physical distance between them. You call this tap is called standard tap. So this is more like a concept, or like a reference. You fix one tap, and want to see the relation between these two taps is called another tap is called use tap. That's one point. The other point is that you really, according to the government or the world, this world, there is something called standard tap. But this concept normally doesn't exist because in your country maybe you think the temperature to 40 degrees is a normal one, so you treat as a standard tap. But in other country, minus 20 is a normal one. They might use minus 20 as a standard tap. So it's just a concept. As a concept, you can treat as a real tap as well. But take this one as a real one, and you use this one, and based on this knowledge. Okay. So now we are going. So the idea is like if I use this tap, you don't have in your hand. You don't have this tap, standard tap, because in your country, the temperature in your country now is 40 degree. But the standard tap, for example, is minus 20 degree now. How are you going to get minus 20 in your country now? No way. So you are going to use this tap, the information you get, and then infer what kind of distance you can get if suppose this tap is exposed to the minus 20 temperature. What kind of so it's a good thing is you can have a universal language. Okay, let's continue. So, but good one. Any question? Just let me know. Just we can have because otherwise we can't have a discussion. So if you have any question, just pop out a question. Okay. So now this is a physical one. You treat this one as a unit. Treat it as a unit. The unit. The name for this unit is called U. You can treat it as V. Okay. So now this reading. I use this meters. Not meter. This tap. I use this standard tap to measure the difference between the physical difference between use tap and the standard tap. So this is the difference, C. This is the difference. Difference C. Okay. So this is the difference. I use a tap, this tap to measure the difference. This C. This C is in the standard meters. I mean standard meters means use the standard meters, standard tap to measure distance. So the distance you get is C. So how much is a C in physical U? How much is C in physical U? The physical U, V is in total is L. Now you measure is C. So in total, this is a physical length. Physical length is C divided by L, V. So this one C divided by L, V. This one, physical length. This nominal length. If you in the tap readings, it will be C. C standardized meters. But if you use this unit as a unit, this V as a unit, that will be C divided by L, V. This one will be C divided by L, V. Okay. Now the relation is constructed again because the whole total your use tap is U. The unit is U. Use the whole this one is called U, and the standard tap U will be equal to V plus this one. The physical length will be the same. So you get this result. So what difference is here you have E is 1 minus something. Here is 1 plus something. Okay, let's come to the next one. Okay, next one. Normally you kind of find this kind of the derivation. It might seem it's quite easy, but indeed it's not that easy. You still need some derivation in order to get this derivation. Okay, now let's come to the next one. Next one is we already measured the distance between A and B. So L stands for the distance use this tape. Use tape. So this is L meters. Use this tape L meters. And what's L meters in U? If you use the unit of U, what's meters U? You'll get this one. Because in total is L. In total is L. You measure this one L, right? But your standard one, not standard one. Your tab is L length. So how many times you have to measure this one? You need L divided by L times. If we use U, use this U to measure it. How many times of U here to? So this is the under one is a physical one. You really measure this one by U. So U means how many times you have to move. Use you move here. I mean head to tail to head. You move this one and then you put this head again into this tail and keep on moving. Head tail, keep on moving until you finish the distance between A and B. And that will need so many times. L divided by L times U. You need L divided L times. And each time, indeed, the unit is U. So this is a physical unit. This is a nominal unit. This one won't be changed. This won't be the same. All the same. I won't call it all the same because it depends on L as well. You can L over here as well. It also depends on this one. But concept, this L will be U will be this. Okay. So now let's do a derivation. Based on this one. It's easy to do a derivation. So this is L is the nominal meters from your use tab. And this U tab in you have an equivalence notation here over here. Equivalence. It means they are not exactly identical. It just means they have to convert into different unit. This one the unit used is the meters, the nominal. This L. You use this L is a nominal one. You use L this the reading over here as your physical readings. And this one physical one, this the reading L will be equals to this one. L divided L use U. Use this one as a whole, the unit is called U. So you have so many times. So they are identical. Means A and B the same. They are measuring the A and B. But indeed, the meaning is slightly different. The measurement is slightly different. Units different as well. Okay, so now L divided by capital L divided by small L is over here. U replace U with this one because we have already relation U. Equals 1 minus C divided by V. So now we construct, substitute this relationship into this formula. You get this one, and then expand it. You get L. Now we might come to an end. This one again is use this equivalence. Is converted back into another one. Equivalence because this V by using this V is equals L over here. This one is now you convert this U into the nominal one. So it's like physical convert to nominal one, nominal convert to physical one, back and forth. So now you transform this one into the L again. U by nominal is L. Because over here, L over here. So you can cancel out L over here. So what's left is 1 minus C divided L times L. So this is your LS. So LS is the reading you'll get if you use this tape. LS will be the readings on this tape. Of course, you won't get this reading on your tape directly because the length of this maximum length of this tape is standard tape is only this L. But you keep on measuring this one head to tail, record all of them. Eventually, you add it up. You'll get this number LS. So LS is your final number. So the good thing about this one is I don't really need to have a standard tab in my hands. Normally you don't have. But once I know the relationship, I know the difference between this C. This C normally, in this case, this C normally you can get from the company. If suppose they produce this kind of standard tab. They might tell you under which temperature they might elongate to how much. So they'll give you this C. So you will get this C. And based on this information, you can get without using the standard tab, you can get the what if I use standard tab, what kind of number should it turn out? Easy, it will turn out to be LS. Powerful, right? Because you can easily convert different one. So easy one. Next one is the same. Next one is the same, but this is more like the. I don't know which one I choose. Maybe I choose it as your homework. So you have to do this one. So the nominal one is overshoot over the standard one. So it means that in essence the length between A and B is supposed to be longer. Because you're supposed to use this one to measure your distance between A and B. Instead, you choose this one. So it's supposed to, when you finish the reading from this one, you're supposed to add up some errors in order to get some correction to get the LS over here. So the correction will be after the correction. This C divided by L will be your correction. So C1 plus C plus this is your nominal from your use tab. So the standard tab, the reading, or your notebook to record all the readings. You add up all the readings from the standard tab. You'll get this number. This number can be calculated instead of a physical measure. Do the physical measurement, it can be calculated just through this one. Once you get the use tab, you can easily convert into standard one. And then we have a common language. Once you have a standard one, you can talk to people. What's the standard length? Then people can understand. Oh, okay, you are talking about which one? Otherwise, you are talking about Celsius, and I'm talking about Fahrenheit. There is no common language. You got to convert each one to the other one in order to get the same language. And then this is a way you convert. Okay, so. And I expect your solution, last time's homework, expect your solution look like this one. So C is the measurement of the standard tab, via the standard tab, you'll get this C. And this C normally you can get from the production company, they have a different kind of equipment to measure under different temperature, what's the influence on the tab, on the steel tab. Okay, regarding this tab correction, any problem regarding this one? Yes or no? Because we are going to move on to next stage. We're going to move on next stage. So far we have learned two correction. One, the length, is overshoot or undershoot. This is undershoot or overshoot in comparison to standard tab. Last one, how are you going to standardize your distance? Through this formula and this formula, you can standardize your nominal distance via the standard distance, one. Last one. And the second one, we talk about the slope. In the very beginning, I just mentioned the slope. So far, you suppose you are able to do two tab correction. One, overshoot, undershoot. This is one. Second one, the slope one. So far, but this is much more like a general one. The general one. In order to solve to get this C or something, you need a specific one, physical one. Because what caused the difference between C? This might be another one we're going to delve into. Because the way how to calculate C is basically is regarding to your temperature, regarding to your force, and regarding to something called sag, different kind of. And we also have something called mean sea level. We are going to tackle that problem. That's another variant of our slope. Okay, let's come to our today's main one. This is just let you know how to do the derivation, and you can get this result, a new result, and it's a good one. The simple, but it takes some time to figure out. Otherwise, this error is equals to this error. It's very confusing how to make a correct correction. So this takes some time to come up with this kind of mechanism. Okay, so let me close it, and then we continue today's today's. So we talk about this one already. We don't look back at this one. So now let's come back. Let's go back. The next one we are going to correct is temperature. Temperature. Why temperature is so important? Temperature because now you normally temperature influence more on steel tape. And normally we are people tend to use steel tape nowadays more because it's easier because it's harder rather than like a soft one. It's harder, so I think it's easier. I promise you, I have to post some of my previously recorded video regarding how I use all these mechanisms and all these kind of tools. But maybe later on. Now is focus on how to do the theory bit. Okay, so you also have a correction because if the weather you have some standard weather, for example, the temperature is let's say 30 degree. 30 degree probably is normal. I mean, let's treat as a normal 30 degree, and then this one will be the physical length will be this one. Then you can define this physical length. Let's say this called U. You can define this one as your standard tape, and then of course you can standardize and also standardize this reading as well. So you will notice correspondence between the physical one and the nominal one. It will come under 30 degree. But now the thing is if you change the temperature, if you change the temperature, you are using this tape in other country. This is your referred or reference tape over here. But now your country is harder. Let's say if you are living in now, some of you are already you come back yet. Some of you are in Africa. For example, you are living in South Africa. South Africa probably now the temperature I don't know. Assume now temperature is 55 degree, 55 Celsius. Probably it's too much, but let's assume. Okay. So it's 55 degree. So if you use a steel tape, you are measuring some your tape is will elongate a little bit. So it might elongate the standard tape under 30 degree tape is over here. But now the tape is elongate. Let's exaggerate a little bit. Maybe normally the tape won't be elongate to this degree. But let's exaggerate. So this elongate come from the temperature because the physical one this is a steel tape. So it's made of steel. Made of steel, they follow the law of physics, the physics law. And the physics law says when the temperature is high, the metallic element tends to elongate itself. So this one will elongated by this degree. So this is 55. So there is a formula over here. How do you get this one? So this might be another reason why there is the use tape. Different from the standard tape, and there's one of you who asked me how do you get the standard tape? So in this case, I just standard tape is just an idea. I just let you know you fix some condition. You can treat this as a standard one, and others they will be changing, and how much they change. This CT will be changing according to this physical law. Of course, there are some derivation. This is our main purpose. So because we just take this one for granted. But some physical lectures, if you attend some of my physical lecture, maybe we can really a proper derivation of this one, but not now. Okay, so how are you going to make some correction? You have alpha over here. Alpha is called what? Alpha is called coefficient of thermal expansion of tape material. Basically, the unit of alpha is like meters. You can identify is a meters Fahrenheit. It means every Fahrenheit how many meters is going to expand. The higher if your Fahrenheit is higher, you have the Fahrenheit is higher. You tend to have meters, much more meters because it's this alpha. Alpha is higher. Alpha is higher means every Fahrenheit, every 1 Fahrenheit, you have a higher expansion. So different kind of material. You can also have like a copper tape. You can, if you are rich enough, maybe you can use your gold tape. So but different tab, they have a different the what I call the thermal expansion. So this one basically based on some material. So I won't call this alpha is universal because even different elements are different. They have a different expansion. So this alpha basically you can treat just like the normal tab people tend to use. People tend to use the metallic one is a steel one. So you can treat this expansion for steel. For steel. But of course, if I go delve into much more detail, I really care about very, very detailed things. You have to figure out different metals. Different metals, they have a different alpha. Of course, the different alpha. Of course, their response reacts to different temperature. Have a different reaction. So that's quite normal, physical one. So, but here we don't have this kind of distinction because otherwise we'll become like physics. We focus more on survey. So let's treat this one just like a steel. Okay, so this one alpha will be some kind of you have to find out the material of your tab. Let's say just this material we fix it to the steel for the moment. Okay, so T0 is your standard. Is a standard temperature. Here in this case is 30 degree. And it's not standardized. It doesn't mean T0 is fixed. In this world, there is nothing called the standard temperature. Because how do you treat the standard temperature? Because the temperature varies so much. So there is no standard one. But once you fix one, that one is called standard. That's the basic idea, principle. So there is nothing called standard. All standard is a local standardized. But it's not universal. So this T0 is treated as a local standardization. So maybe from one company, maybe from one country, maybe from one government, and so on and so forth. So T0. And Tm is your measurement. Tm is your measure over here. Here is called M stands for mean field temperature. Because you want to be calculated to some degree. So use mean value means you 55 doesn't mean from one moment. It means it's a process till one day. The overall is 55 55 Fahrenheit. So this is the idea. So Tm will be 55. But this 55 is the average temperature about one period of time, rather than just 1 point. Because at 1 point in the middle of the day, the temperature, the sun is tend to be hotter. So you can't just take that temperature. So you have to average out the other temperature as well. That one will equal Tm. So M stands the mean, temperature. Here you have a field. So it means that because you are using a tap outside the room normally. So you have to use the we call field temperature. Otherwise, that by some distortion as well. Okay. Let's come to the next one. Next one is T0 standard. I just called you a standard. Okay, so L here is the distance between A and B. A and B. So you do this kind of correction regarding to L. So use your tab reading. So this L comes from this one. Under this 50 degree temperature, I use this tab. The tab I use this tab. This tab can compare to be elongated, but I use this tab. I treat this one as a V. In our previous one, I use U and V. I use a V for the standard one. So let me correct this one. U and V, right? So now use the physical U, this one, to do the measurement. And then the reading. Use suppose this reading is L. This length is L. Use repeat and consequently measurement. You can get in total you get L. From the distance A to B, you get this one. Okay, so now you are going to convert under this 55. You are going to convert to what if I use this tab under the temperature 30 degrees? How much I'm going to correct? And so if I can use LS. What's the LS? The standard tab. What's the reading of the standard tab? What is standard? So this is the one I keep on reading for standard tab. So what you get is you can get this one. Of course, your L minus this one. L is your whole bit. So your LS will be what? LOS will be your nominal, this one, this one. And there is in my minus, in my plus or minus. Why? Depends on what? Depends on the temperature. If temperature is higher than standard one, then your tab is elongate. Your tab will elongate a little bit. So if your tab is elongate a little bit, it means you are undercut. So this is a plus. So plus is like temperature. If the temperature is higher, if a plus, this a bit counter your intuition. You think about it. Let me repeat again. Why the temperature? When temperature higher than 30 degrees, your standard one, you use a plus. Otherwise, if this is 20 degrees, use a minus. You use a minus. Of course, this is the correct one. This stands for the temperature correction. The temperature correction for the temperature correction for temperature. Okay, so let me emphasize. When do you have to use plus? When do you have to use? For example, if you are 30 degrees, right? This is your standard tab. But now the tab will be elongate this big. So the tab become bigger. The tab become bigger. But the real tab is a standard tab is shorter. So you're supposed to have a much more reading. You have to use this V, much more V to do the measurement. You use in comparison, use less V in comparison V to do a measure because this is longer. So V is supposed to be V is supposed to have more times V than the U. So in total, because this is an error as well, I don't put it error. Put this error. So this is error, this is error. So I tend to have much more length over here. So if you use this reading, you have to add up much more reading over here. So let me write in this way. Then you can solve this problem forever. So this will plus this one. If what? If Tm, your mean value, your mean field temperature. If your mean field temperature is higher than your T0, T0 your standard temperature here. You are 30, the degree you choose, 30 degree. Okay, so I just put into a formula. Then you can read from this form, and again, you don't think about when do I have to use a plus, when do I have to use minus. So and use L is a nominal reading from your use tab. This is your use tab, and this is your reading from your standard tab. Is a C minus CT. How do you get CT? CT is over here. CT is over here. So, and if Tm is less than T0, you have to think about this one because I know it's hard to get it here wrong, but you have to think about how come this just like I say, whether it's the temperature higher, it will become longer. I mean, comes you over as you underestimate because it's already this one already become too big, This one become too big, so the U you can't too many U can't be. The reality is supposed to be this short, so you can have more V. Even more V, you in reading you have more error over here as well. So in total, your temperatures are higher. In reality, if you in reality you tend to have much more length over here. So you have to this length over here you have to plus. Think about in this way is easier. If you that one is shorter, so you already overestimate the distance. So you if it's shorter, use this shorter one to do the measurement between A and B. This one you will overshoot as well because the typical one, the standard one is this one. And use this one. So you have much more U. So error is much more U means much more error. So error being calculated too many times. So overshoot it. So you have to deduct it from your this one. So you have deduction over here. So easy to figure out this one. So hopefully you can fully understand this concept. Later on, we will give you some example, and you can figure out how to use this kind of knowledge to do the I think so we passed the break time. Okay, let's take 5 minutes break because maybe some of you can remind me because otherwise, at least you don't need break. I only probably need 1 or 2 minutes. But anyway, let's take short break. So let's come back at 15. Let's say 25, and think about what I just told you. What's the why temperature? You have one is plus, one is minus. Always think about this one, and will be fine. And later on, we'll put every factors into consideration, like temperature, force, and sec different kind of influence to into consideration, and then we'll see what's the correct length for the standard tape. Why do we care about so much about standard tape? Just like I said, universal language. Otherwise, who trusts your tape? No one trusts your tape. So your job is to convert the used tape into the universal tape. There is nothing called universal tape. At least convert to some called standard tape. So you can specify them by your standard. Okay, let's take short break. As